Hey world, this is Vrat Soni and welcome to the another video on this channel. Today I'm gonna show you a quick overview of our assignment, what we have made. Basically, I and my team worked on a project called Heart Disease Detector, and with the help of neural networks, we trained some of the neural networks and we checked the accuracy. So let's deep dive into it. First of all, this is the name of my team members. I and my team perform some of the major models of neural networks and we check the accuracy as well. So let's take a look. First of all, we imported some of the essential libraries. First things first, it's a NumPy library and we have imported some Keras models as well in order to perform some major tasks. So let's get going. After that, we have read pd.read csv file. It is a kind of csv file. We took it from Kaggle and we cleaned that data set. So this is what it looks like, the first 5 rows from the head function. And we have some of the major columns such as BMI, smoking, physical activity, generation, health, physical health, mental health, and many more columns we have in this data set. It is almost 18 columns, but some of them are like some of them have certain kind of values which some of them have a certain kind of values which is not supported by the, I can say, but it has yes, it has a very good and all that as a values, but we are not gonna work with that. So what we did is we translated this all I mean words into a into an integers. So let's take a look. For first of all, in a smoking column, it says smoking, so it has a yes or no. Basically, we are not gonna work with that in a neural networks. So what we did is we converted into the integers of zeros and ones. So we created all the columns into all the column values into zeros and ones, or maybe 0, 1, and 3 between that period. So this after converting into the integer, this what it looks like. It looks pretty good because it is very easy to deal with the integers rather than with the words. After that, we are not gonna use all of the columns, and as to use all of the columns is a kind of bullshit. So we took some of the columns, like eight major columns. So the first eight columns, so it's like 0, 1, 2, 3, 4, 5, 6, 7, and 8. So till here we neglected this some of the column in order to get the better accuracy of a model. So let's get this running. Oh, it is working perfectly fine. After that, it we have created one variable called x and we stored in it. After that, we created one variable called y for the target. We used this as a target variable, and we include the my minus one column is the last column of our data set. So it says heart disease if we have or not. It says all the zero, that means we do not have any heart disease. But if we take a look at the tail column, so yeah, we do have some of them, such as here it's one. So yeah, it's pretty good. Let's change it back to head. So and we can see we have almost how many rows in this, almost 3,19,000 rows in this. So it is a pretty big data set. So yeah, let's keep going. So first of all, after that, oh, here it is. So now, with the help of sklearn model, we use that data set and split that into train test split, as it is a very beautiful function to split the training and testing data. So for example, it's like a x train, x test, y train, and y test as a variable, and it is this function. We call it in a function, and we split that data set into 70% training and 30% testing, and we set the random state as 1 2 3. So it is working perfectly fine. Let's see the data set, what it's look like in the array form. So this is the training variable and this is the testing variable. So it looks pretty good, decent, I mean. This is x train, I mean y train y test. So if we look at the length of x test, just in general, so it says we have 95,000 rows as a length of x test, and x train will be 22,23,000. Wow. Let's keep going. This is the shape. Then now it's time to perform some of the changes, or now it's time to perform the neural networks. So for that we have imported this library, and we imported two categorical. Now I'm gonna convert these two categorical values. So we have made one hot train labels and hot test labels to convert these values. So in order to convert these values, we use this method to categorical for y train and y test. It is working perfectly fine. Now moving towards the next step. Now it's time to train our model. It is pretty good. From Keras import models, and so from Keras we imported models and layers as well. Model equal to model dot sequential. Now we start to train our model, and now I'm gonna add some of the hidden layers as well. With so we have added two hidden layers with 100 neurons each, and with the activation function called ReLU. Sorry. Now for the output layer we used two neurons and activation function softmax. As we all know that we all always, I mean in most cases we use softmax as a output layer. And now I'm gonna compile this model using Adam as an optimizer, loss function as a categorical constropy. As we all know that for binary classification we use categorical constropy and a matrix equal to accuracy. Now let's see the model summary, and we use the callback function as well in order to finish this epoch. Call this function. Now I'm gonna fit this into the model. So this is the fit function, and this all we do. After that we use the test loss and test accuracy to see how much we have test loss and how much we are gonna get in the test accuracy. So let's print that out. Apart from that, we use the matplotlib as a library to plot the graphs to plot our result. So let's see. I guess I'm running this again. It will take a bit of time. So let's wait for a 5 more seconds. As in the meantime, I'm gonna show you the other part of the models. So let's get going. So this is the first model, and so now we have tried to see the other accuracies as well. So for that we have tried this as a second model. It is kind of same, but we did some minor changes. For example, we have it is the same model as the first one, just we add some of the dropout layers to deactivate some of the neurons. So we used 0 0.5 as a dropout layer in after both of the hidden layers, just to deactivate some of the neurons. uh, Other than that, everything is the same, and besides we use matplotlib.pyplot as a library to plot the result. Okay, so here we go. It all loaded, and this is the summary of our model, and this is the epoch. So we are getting 91% accuracy, which is pretty good, but other than that we are getting kind of overfitting, because it is a kind of basic overfitting we have over here. So let's see what other models looks like. I'm gonna comment this one out and run the other one because we cannot. I'm gonna comment this out and run the other one because we cannot run two model at the same time, as you all know that. So this is the training accuracy and this is the validation accuracy. 91% accuracy, which is not very good, but it's better. Let's uncomment this one and I'm gonna run it again and see what's the result look like after adding the dropout layer. So over here it shows me I got a 91% of accuracy, 91.25. Let's see how much accuracy this one is giving after adding two dropout layers. And also I used one more hidden layer in this. Let's see how it goes. After that we also train one more model. It is a kind of simple. We just used two dense layers, I mean two hidden layers, so one with 32 neurons, same as the first one, but we have over 32 neurons, and over here it has 8 neurons, but in the first one we had almost 100 neurons in each layers. Other than that, the changes we have made is here we used optimizer as RMS prop, but in the first one we used Adam as an optimizer. So that's the bit of difference we did, and let's see how it goes. I am not sure about the accuracy much because I cannot see much of the difference over here. Okay, so yeah, I can see some of the changes like over here I got accuracy as 0.9125, and in the first one I guess I got the same 0.9215, but I got some of the changes after adding the dropout layer, and here is the changes. So what I got, it is not a very big change, but yeah, something is better than nothing. Now I'm gonna comment this whole model out and I'm gonna run the last but not the least. I'm gonna run the last one. Let's see how it is giving us. We tried to clean our data, but we did a lot of research on that. uh, However, we are not getting the result what we expect. We were expecting around 95 to 96% of accuracy, so there that means 5% would be overfitting, but in this case we tried a lot and we are getting almost the same accuracy like 91%. So that means around 9% we have overfitting in this model. After changing the neurons and output layers, I'm not sure how it goes. Let's see, we have 30 epoch and it still have till 10. Still 3 more to go. Oh, I mean, we just have 20 epochs over here, so we would be pretty good in a few seconds. And Perfect. It's done. Because just we had only 20 epochs in this section. Let's see how it goes. It is giving us the same accuracy, not much different, a kind of it is much more similar, just the last number will be the different. Other than that, everything is the same. We do not have any test loss because we just have had only two features in the target column, the yes or no. So yeah, that is what we did. We tried some of the models to predict the heart disease as a heart disease detector, if a person is getting heart disease or not, with the help of a neural networks, which is pretty good in the field of AI. So yeah, this is it. Thank you for watching this video and have a great day.